Okay, now we are going to look at how we can shift functions. So we've talked about reflections in the last video. Now we're going to talk about translation. So we're talking about a rigid movement where it slides left to right or up or down. Okay, up or down is easy. We're used to things moving up or down based on y-intercepts. Nothing has changed with parabolas. The y-intercepts are always our c value. So if you see a c value, then you know it's going to be shifted up or down in comparison to a parent function. So our parent function in this case is y equals x squared, just like it was before. If it were to be a parabola that has shifted up, we would want to see something like this. Y equals x squared plus 1. Okay? This y-intercept right here is now here. Okay? So now it's just shifted up one value. So that means this has moved here. We got this point here. Everything has shifted up one value. There's my new parabola. Cool? Awesome. All right, so if it was going to shift down again, I'm going to see a change in my y-intercept. I would see something like this. Y equals x squared minus 2. My y-intercept is now at a negative 2, meaning like if I put 0 in for x, 0 squared is 0 plus minus 2 is negative 2. So my y-intercept is at negative 2. Again, it's a parent function where the axis of symmetry is just this y-axis, so it's nice and easy. I don't have to worry about how it's shifting left to right as of right now. So I can look at this. Here we go. Everything has essentially shifted down 2 units. I can do the same thing over here. Everything is shifted down 2 units. Makes graphing these things pretty darn easy. Cool? All right, so if I was shifting it up or down, I'm looking at just the y-intercept changing. Now, if I'm looking at how it's shifting left or right, that gets a little bit more complicated. That gets more complicated because if we're shifting something left or right, we have to think about what the axis of symmetry equation is. Axis of symmetry equation, x is equal to negative b over 2a. I don't have a c value in here. I'm looking at how this b is changing now in comparison to how the a value is changing. So if I'm looking at how it's shifting from left to right, I need to pay attention to its middle term this time. So I wrote stuff in here and now I can't see it very well, so I'm going to erase all that. Now let's look at how it shifts from left to right. I'll add that here. All right, so if we wanted to see it shift left, we want to see this b value because we have a negative b over 2a. If we want to see it shift to the left, that means this b term has to be positive because we need it to turn negative so it shifts left. All right, so we would be looking at something like this. Y is equal to x squared plus 6x. Again, we aren't looking at it like changing width or anything like that. And now we also have a y-intercept of 0. So we're back here with a y-intercept of 0, but we've shifted over. So our axis of symmetry is going to be shifted over a little bit. So if I look at this, I have negative 6 over 2 times 1 for my axis of symmetry. Negative 6 over 2, negative 6 over 2 gets me negative 3. So my axis of symmetry is negative 3. And my y-intercept is 0. So that means I've also probably shifted down a little bit with all of this because of how this axis of symmetry has changed. So I now need to put this negative 3 in here and actually figure this out. Negative 3 squared is a positive 9 plus 6 times a negative 3, which is negative 18. So 9 plus a negative 18 is negative 9. So my vertex now is negative 3, negative 9. So it's all the way down here. So I'm looking at a parabola that's going through here. I've now shifted to the left and I've gone down. All right. Now, if I want to shift something to the right, y equals instead of it being a negative or a positive 6 here, I want to see a negative number potentially right there. Y equals x squared minus 2x this time. Let's see what happens there. If I have negative b over 2a as my equation for axis of symmetry, I have a negative 2 times 2 times 1. So I get 2 over 2 or 1. If I put 1 into all of this, here's my new axis of symmetry. And I'm going to put 1 in here. 1 squared is 1 minus 2 times 1, or minus 2 is a negative 1. So my vertex 1, negative 1. And then here. So I've now shifted over here. So I can see how it shifted to the right. Now it shifted also up and down, or in these cases both down, because of how I set up the equation. So I probably should have been more thoughtful in how I set up the equation to like account for this only shifting to the right or to the left along the x-axis. But at the same time, what you can see is if you want to see a shift, or if you see a shift to the left or to the right, you need to see a change in your b value, or you need to see that there is a b term in your equation. All right, so wrap it up. If something is shifting up, we want to see an increase in our c term in our equation. If we want to see it shifting down, we want to see a decrease in that c term. If we want to see our equation shifting left, we want to see a positive b value or b term. If we want to see it shifting right, we want to see a negative b term. Cool? Cool. Awesome. Bye.